Well, hello and welcome to episode 5 of Bite Sized InfoSec. Um, Today's just another toast sandwich made at home. But what I'd like to talk about today is sort of NTP. Some of you may have seen today that on Cloudflare's blog they've been talking about their NTP secure implementation, the fact they're now offering time.cloudflare.com as a time source. I'm still going to talk about a little bit of NTP, how this secure thing works, why it's good, what they've kind of forgotten to talk about. So they sort of, I found the way that Cloudflare wrote the blog post made it sound like they're sort of the centre of it all. This NTP security or NTS. It's an RFC, just like NTP is itself. There's lots of other organisations working on actually implementing the clients and the servers. So it's not just Cloudflare. Cloudflare is just going to be one time source. So what does this add about previously? NTP, it's already has things like AutoKey, which was sort of meant to offer some sort of authentication, so you couldn't have malicious time updates, pretend to be a server, replay time. When I say replay time, I mean replay time NTP messages. But AutoKey, just the setup and sort of everything had to sort of be symmetrically authenticated. It was quite a logistical effort, and it never hasn't really caught on particularly well. What NTS gives you is you do an initial authentication over TLS using standard CA certs to provide trust. So that's all good. And then over that you exchange some sort of session key, which allows for symmetric encryption, which is a lot faster. I haven't fully read the specification and the documents around it, but from what I've understood currently is the actual time data is still clear text, because there's no confidentiality required in that. It is the time, and from what I can gather, it's that way so you can process it really quickly. There's no overhead when you get the actual message to get the time and sort of timestamp it internally, so you can start doing the calculations on it. The other sort of the metadata around in the packet around the time, that is signed and encrypted, so you can verify that it has come from the server you're expecting it to. It's not a replay or anything like that. So I think this is really good. Be interested to see how well it catches on. And the big thing is with NTP is sort of currently in everything. Everything kind of supports it. Windows does, all your network devices do, your phone does, your computers do, your Linux boxes, your Unix boxes. So sucking the benefit of this, you need the client and the server to support it. So that may take some time, but it will be good to see, because one of the big things sort of missing from the blog post was the fact that you should be using multiple upstreams, multiple different organisations to get your time from. And let's take a step back. Firstly, you should have every NTP client should have 3 or more upstream servers. and preferably an odd number of servers. So, and I'll get you why you have 3 or more. It is so that if you have one server, you never know whether it's giving you time. You have to believe that. You never know whether it's the correct time or it's bad ticking. If you have 2 servers and the times differ, NTP can, this is all built into NTP, this is what NTP, the client, does. You've got 2 times, knows that, and they're different. Goes, okay, one of the times chances are is correct, one of the times is incorrect. In fact, you've only got 2 servers, you don't know which one is correct and which one is not correct. Particularly if they drifted slowly over time, the NTP client can't work out which is why you have 3. So with 3, you're going to have 2 that agree, 1 that disagrees. Unless there is a malicious actor involved, chances are that the 2 that align are most probably the correct time, and the one that is incorrect, the one that differs from the other 2 chances are is the incorrect time. And so that's why you sort of have 3 or more, so you can do the bad ticket detection. And why I say having an odd number is good, because if you get groups, if you sort of get 2 times, it means that if you've got an odd number, half is always, you're always going to have a quorum less than half or 1 more than half. If you've got an even number, you can get split down the middle, so you can get a split brain type situation. But with a odd number, you should always hopefully get greater than 50% quorum, and that could be the one you go with. And why I say more than one upstream organisation, and particularly type as well, is that gives you, it means if there is a malicious actor in one organisation who you're getting your time from, that's not going to affect your time, because your bad ticket detection is going to detect that bad ticking and remove it from the pool. So that's why I say multiple different upstream organisations. So you could use, let's put aside all the other Cloudflare ethical issues that they're having at the moment. You could use Cloudflare as one NTP source. You could use NTP pool as another time source, assuming they themselves, the ones you talk to, don't use Cloudflare themselves as their upstream. And then you could say in New Zealand you could use the Domain Name Commission, Internet NZ. They also run some New Zealand-based NTP servers as well. So you can get 3 different organisations quite easily. And you could run also an NTP server based off GPS yourself as well. And that just gives you some differences in your where your time's coming from. So now if someone wants to get incorrect time into your network because of a whole range of attacks, some of those I talked about in my DEF CON talk a few years back, it's a lot harder for a malicious person to change the time inside your organisation. And that's one thing I think was missed from Cloudflare's blog post, is using multiple different time sources. Multiple different time sources, and also multiple different time sources from different organisations. The NTP will sort of use up to 7 or 9, but you can give it more than that, and it will just sort of monitor it and pick sort of 9 or 7 of the lowest jitter to use. And that was one thing that Cloudflare did mention was something they could do quite well, was they had they've got lots of points of presence, so they can get the jitter down quite low, and also fact where they're located, having asymmetric inbound and outbound paths shouldn't be so much of a matter because they are close. So that also helps improve time. So be interested to see. I think it'll be interesting to see how sort of the adoption of NTS happens over the next few years. So that was episode 5 of Bite Size InfoSec. Make sure you like, thumbs up, click subscribe, click the notification bell, do all that stuff. Follow on Twitter. Join Patreon, all the relevant social media, end of YouTube buzzwords that you meant to insert them here. Go do them. Thank you very much, and until next time, see you later.